Hello, my name is Ray. I'm the Ray in the Ray code. In this video, I'll be covering the factory design pattern and I'll be using C++. Now, I have put timestamps in the margin so you may navigate to the section you desire most. My favorite is the SWOT analysis. Now, I have used other programming languages to cover this design pattern, and I have used this programming language across all the other design patterns that were given by the Game 4. Please like this video and leave a comment. You can find me on all the social media platforms. Search them out and become the Ray Code groupie. Please share this video with others. The factory design pattern deals with the problem of creating objects without specifying the exact class of the object that will be created. Instead of calling a constructor directly to create an object, a factory method is employed to create the object. The factory method is typically defined in an interface which is implemented by concrete classes. The pattern is thus delegating the responsibility of object instantiation to specialized methods, rather than directly instantiating objects with constructors. There are variations of this pattern, such as simple factory, factory method, and abstract factory, which we discussed earlier. But at its core, the factory pattern revolves around the idea of using a method to produce instances, abstracting away the instantiation logic. Important for a C++ developer. Decoupling. The factory pattern allows for a decoupling of the client code which needs the object from the code that instantiates the object. This decoupling means changes in one area, like adding a new object types, are less likely to impact other areas of the code. Flexibility. By deferring object creation to a factory methods, it becomes easier to introduce new object types without changing existing code. The client simply interacts with a new factory or modified factory to get the new object type. Centralized object creation. By centralizing object creation process, the factory pattern ensures consistency and can lead to easier maintenance. If there is a need to change how objects are created, it's done in one place, the factory. High complex creation logic. Some objects might require intricate setup before they are ready to use. The factory pattern can't hide this complexity, ensuring the client receives a fully instantiated, ready-to-use object. Dynamic runtime decisions. The factory pattern allows for decisions about which classes to instantiate to be made at runtime based on certain run conditions or parameters. This brings about a dynamic aspect to object creation. Better resource management. C++ being a language where resource, typically memory, management is crucial, factories can help ensure that objects are efficiently created and destroyed, assisting in resource management. Consistent object initialization. If there are mandatory post-construction steps for an object, e.g. setting certain fields, initializing resources, a factory method ensures these steps are always executed, guaranteeing a consistent state for each created object. In summary, for C++ developers, understanding the factory design pattern provides a powerful means to abstract away the complexity and intricacies of object creation, resulting in a cleaner and more maintainable and scalable code. UML for the factory method with a focus on C++ students. Product. Why? To define a common interface for all objects the factory will create. Function. Declares the operations that all concrete products must implement, ensures the client can use products without knowing their concrete type. Concrete products. Why? To provide actual implementation of product interface. Function implements the behavior defined in product, represents the specific object that gets created by a corresponding factory. Name. Creator. Why? To provide actual implementation of the product interface. Function implements the behavior defined in product, represents the specific object that gets created by a corresponding factory. Name. Concrete creator. Why? Define the factory method concrete abstract and centralized object creation logic. Function declares factory method, usually virtual and pure. Virtually in C++ may implement an operation which calls factory method, uses the return product as the abstract layer between client and concrete products. I hope you're enjoying this video. Be sure to like and comment. If you have an improvement I could use, just let me know. Hello, my name is Ray. I'm the Ray in the Ray code. Today I want to discuss the factory design pattern using C++. The factory design pattern is a creational design pattern. In our demo, I will be talking about the creation of shapes like a circle and a square. We start with a shape class, the base class for our shapes. We have the class structure, and we add IOStream at the top. We will create a virtual function draw for polymorphism, and we do some cleanup. Now we will create our shapes. We start with a circle. Here we have the class structure. At the top, we include the shape interface we just created, so we can extend this class with it. We add a draw method that returns a string inside circle draw method. The next shape I want to create will be the square. We have the class structure. At the top, we include the shape interface, so we can extend this class with it, and we override the draw method to return the string inside square draw method. I think we have enough shapes, so we will create a shape factory. We have the shape factory class structure. We include shape and the shapes we created. We have the string file so we can write out our results. If the shape is circle, we return a new circle. If the shape is square, we return a new square. Now let's go to the index page for our demo. At the top, we include shape factory and memory. We no longer need IOStream because we have it in the shape factory. We initiate a shape factory. We set shape 1 to a circle and draw it. We set shape 2 to a square and draw it. I think we are ready to compile and run. We get inside circle draw, inside square draw. My name is Ray. Always go with a smile. SWOT analysis of the factory method design pattern for C++ students. S. Strengths. Encapsulation hides object creation logic, reducing dependencies on concrete classes in C++. Extendability. Adding new object types requires extending the factory without modifying client code. Polymorphism. C++ supports efficient use of polymorphism to create objects dynamically. W. Weakness. Virtual function overhead. Requires the use of virtual functions which can introduce minor runtime overhead. Code proliferation. Generates additional classes and functions, increasing the complexity of smaller objects. Manual memory management. Improper handling of dynamic allocation objects can lead to memory issues. O. Opportunities. Game development. Frequently used to generate game entities or levels in dynamic C++. Plugin frameworks. Suitable for building extensible architectures in C++ systems. Cross-platform compatibility helps developing portable object creation mechanisms for C++ libraries. T. Threats. Performance risk. Overuse of virtual functions in dynamic allocation may degrade performance in high-throughput systems. Over-engineering. Misapplication in simple scenarios might unnecessarily complicate the code. Modern alternatives. Concepts like templates and context expression replace factory patterns in some scenarios. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment, and if you find me on the social media platforms, leave a comment there. Tell a friend the Ray Code is awesome.